Hi everyone, today we're doing Math 6, Mission 8, Lesson 11, Deviation from the Mean. Let's study distances between data points and the mean and see what they tell us. Warm up, here we go. Elena, Jada, and Lynn enjoy playing basketball during recess. Lately, they have been practicing free throws. They record the number of baskets they make out of 10 attempts. Here are the data sets for 12 school days. So we have 12 school days and they record the number they make out of 10. Okay. Calculate the mean number of baskets each player made and compare the means. What do you notice? All right, so in order to figure out the mean, we add up all of the data points in each set and then divide by the number of data points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. So we know we're dividing by 12. We're dividing by 12. All right, so let's start with Elena. I'm going to say that's an E. So we have 4 plus 5 plus 1 plus 6 plus 9 plus 7 plus 2 plus 8 plus 3 plus 3 plus 5 plus 7. Woo! That's a lot. Here we go. 4 plus 5 is 9, plus 1 is 10. I like to group by tens. 2 and 8 are 10. And 7 and 3 are 10. So I'm going to erase this and I'm going to write this plus 5 plus 3 so that my 3 and my 7 are together to give me 10. All right, now let's add these all together. So I know that 6 plus 9 is 15. And I know that, 7 plus 3 is 10. And that just leaves me my 5. So 10, 20, 30, 40 plus 15 is 55 plus another 5 is 60. So that should be 60. And then we need to divide that by 12 because that's the total that we have. So 10 goes into 66 times, so 12 would go into 60. Let's try 5, because 12 is bigger than 10. So if I do 12 times 5, let's see if that gets me 60. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6, 60. So 60 divided by 12 is 5. So for Elena, our mean is 5. Let's go for Jada now. So we have 2 plus 4 plus 5 plus 4 plus 6 plus another 6 plus 4 plus 7 plus 3 plus 4 plus 8 plus 7. Let me make sure I have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 data points. All right. You know I like to group if I can. So 4 plus 6 is 10. 6 plus 4 is 10. 7 plus 3 is 10. Looking pretty good. All right, so then we have 4 plus 5 is 9, plus 2 is 11, so this would be 11. And we have 4 plus 8 is 12. And 12 plus 7 is 19. All right, so we have 10, 20, 30, 41. This we write down. 51 plus 9 equals 60. And 60 divided by 12, oh look, we've already done that math, so it equals 5. So Jada's mean is 5. Let's see Lynn's. Okay, here we go. 3 plus 6 plus another 6 plus 4 plus 5 plus another 5 plus 3 plus 5 plus 4 plus 6. Oh, and I'm going to erase this a little bit so I have more room. Plus another 6 plus 7. So I want to make sure I have all of my data points, so I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're good. Okay, here we go. You know I like to group. So there's 6 plus 4 is 10. 5 plus 5 is 10. 6 plus 4 is 10. All right, that looks, oh, we could do 3 plus 7 gets us 10. And that just leaves us 6. And then 5 plus 3 is 8. And then we have this 6 here. All right, here we go. 10, 20, 30, 40. Oh, and 6 and 6. 6 and 6 is 12. So that's 52. And then we have this 8 right here. 53, 54, 55, 56, 57, 58, 59, 60. Look, 60 divided by 12, and we've already done that math, so that equals 5. What do you notice? They all have the same mean. Perfect. That's what we notice. All right, now 2 says, what do the means tell us in this context? So it means that, or it tells us that all of the students, well, the 3 of them, Elena, Jada, and Lynn, make about half the baskets they attempt, right? Because they say up here, they try to make 10 baskets. So all of the students make about half. Ooh, I don't like the word about. Let's do a different thing. They make on average, right? All of the students make on average, because they don't always make half. They sometimes make a little more, they sometimes make a little less. So on average, they make half of the baskets they attempt, right? Because 5 is half of 10. All right. That was our warm-up. Let's keep going. Activity 1. Here are the dot plots showing the number of baskets Elena, Jada, and Lynn each made over 12 school days. 1. On each dot plot, mark the location of the mean with a triangle. Then, contrast the dot plot distributions. Remember, distributions is describing the dot plot, right? The spread, the variability, etc. Write 2 to 3 sentences to describe the shape and spread of each distribution. All right, here we go. Well, we know that the mean for each one is 5. So we're going to do a triangle on 5 for each one of them. Okay. So we marked the mean with a triangle. Then contrast the dot plot distributions. So they're all centered around 5. Because that's the mean, right? Elena's, if I were to take this and split this in half at the mean, Elena's goes like this and like this. So Elena's is symmetrical. Let's look at Jada's. Jada's, likes to jump around. Jada's looks like this. So Jada's is not symmetrical. Let's look at Lynn's. Lynn's goes like this and like that. So Lynn's is also not symmetrical. So Elena's data is symmetrical. But it is also the most spread out. Look, she goes from 1 to 9. Jada goes from 2 to 8. And Lynn goes from 3 to 7. So Elena's data is symmetrical, but it's also very spread out. Like I said, she scores from 1 to 9. So sometimes it is not good, right? She's only scoring 1 basket out of her 10. Sometimes she's really good and she scores 9 baskets out of her 10. All right, so Jada's, we said, is not symmetrical. But her data is less spread out than Elena's. Because she goes from 2 to 8. So Jada's data has less variability than Elena's. And I'm just going to call Elena E. Lynn's data, however, is also not symmetrical. Which we knew, and it is the least spread out. It has the narrowest spread. She only goes from 3 to 7, right? So she has the least variability. So even though they are all centered around 5, that they all have a mean of 5, they are very different graphs. Discuss the following questions. We're just going to discuss together. Explain your reasoning. Would you say that all 3 students play equally well? I would say that Jada and Lynn probably play better than Elena because Elena is the most spread out, right? Would you say that all 3 students play equally consistently? So maybe those are different. So would you say that they each play equally well? Well, they all the means equal 5. So I would say yes, they all play equally well because they all make, on average, 5 baskets. All make, on average, 5 baskets. Right? But for B, would you say that all 3 students play equally consistently? I would say no. Lynn is the most consistent because her spread is the smallest. So her spread or variability is the smallest. So she's more consistent. If you could choose one player to be on your basketball team on their records, based on their records, who would you choose? Because they all have the same average. They make about the same amount of baskets. You could really argue for any of them. But I would choose Lynn because I want the most consistent. I know that she's going to make between 3 and 7 baskets. So I want the most consistent. But you could really choose any of them because they all, when it comes down to it, they all have the same average. All right, activity 2. The tables show Elena, Jada, and Lynn's basketball data from an earlier activity. Recall that the mean of Elena's data, as well as that of Jada and Lynn's, was 5. We do know that. Record the distance between each of Elena's score and the mean. So we're doing distance from 5, remember? So 4 has 1, 5 is 0, 1, from 5 that would be 4. 6 from 5 is 1, 9 is 4, 7 is 2, 2 is 3, 8 is 3, 3 is 2. Remember, we're distance from 5. Again, 3, 4, 5, that's 2. 5, that's 0. 7, that's 2. All right. Now find the average of the distances in the table. So we aren't caring if it's left or right. We are simply adding all of these up, all of the distances from 5. Okay? So now find the average of the distances in the table. Here we go. So this is 1 plus 0 plus 4 plus 1 plus 4 plus 2 plus 3 plus 3 plus 2 and another 2 plus 0 plus 2. All right, so I like to clump. You know I like to clump. So 1 plus 0 plus 4 is 5. 1 plus 4 is 5. 2 plus 3 is 5. 3 plus 2 is 5. 2 plus 0 plus 2 is 4. So we have 5, 10, 15, 24. 24. And how many data points do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12, because remember we're finding the average, so whatever we add up, we have to divide by the number of data points we have, and 24 divided by 12 is 2. So the mean of the distances is 2, and this is MAD. This value is the mean absolute deviation. That is a new term for us. All right, so we are going to take some notes really quick on MAD, because that's the mean absolute deviation. Whew, that's a big term. So we're gonna go up here and we're gonna take some notes. So the MAD, and this might make you mad, But the MAD is the mean absolute deviation. So what is the MAD, the mean absolute deviation? Say that for me out loud. Mean absolute deviation. This is the measure of variability. So the MAD helps us see how spread out the data is, how spread out or closely clumped the data is. All right, so it helps us see how spread out or closely clumped the data points are to each other. So the data points are to each other. Oops. And this helps us understand variability and talk about variability without having to graph it, right? So I'm going to erase that period and add without having to graph / plot the data points. Because remember, data sets can have the same mean without having the same MAD, the same variability. And we saw that with Lynn and Elena and Jada's, right? You can see they all had the same mean, right? This is the mean. They all had the same mean, but they all had different measures of variability. And just like we learned how to calculate the mean, we're going to learn how to calculate the measure of variability, which is the MAD. Okay? So I want you to remember that data sets can have the same mean without having the same MAD. So we're going to write that. Data sets, oh, it jumped on me. We were so close. There we go. Data sets. Oh, it does not like me today. My goodness. I'm going to move this down here. I had better luck when it was down here. All right, third time's the charm. Data sets can have the same mean without having the same MAD. Oh, it still does not like me. So we were almost done. It said MAD. You can go back and pause the video. So mean does not equal MAD. All right, let's keep going. So the value is the mean absolute deviation, MAD, of Elena's data set. So Elena's data the MAD for Elena's data is 2. All right, now it says find the mean absolute deviation of Jada's data set. Okay, here we go. Jada's. And remember, this is all distance from the mean, and the mean is 5. So the mean is 5. Let's see if Jada's MAD is different from Elena's MAD. So distance from 5, we have 3, 1, 0, 1, 2, 2, 1, 2, 2, 1, 3, 2. All right, we're going to add all of these up. 3 plus 1, 0 plus 1 plus 2 plus 2, 1 plus 2 plus 2 plus 1 plus 3 plus 2. And I'm going to find my 5s. 3, that's a 5, that's a 5, that's a 5, oh look, and that's a 5. So we have 5, 10, 15, 20. So 20 divided by 12, ooh, that doesn't go in very easily. So we're gonna have to do some work here. So it definitely goes in once. So let's do that. So 12 doesn't go into 2, but 12 does go into 20 once. So that gets us 12. That gets us 8. Bring down 0. Ooh. 12. Ooh, it says round to the nearest 10th. So I know 12 goes in, bring up my decimal. 12 goes into 60 5 times, right? Let's try 5, see what that gets us. 12 times 5, 10, yep, that's 60. But what about, what's one more? 2, 72, so 6, 12 times 6 is 72, and that gets us 8 again, which would get us another 6, and we're just going to continue on forever and ever. So we round to the nearest 10th. So that would be 1.66, but we have to round. This 6 is above 5, so that pushes this 6 up 1. So our MAD is 1.7. 1.7. So Jada's MAD is 1.7. Did I miss something? Oh, I did something wrong. Do you see that? I said 6 was 2 away from 5 when it wasn't. It's 1. Right there. So that's where I did this. This should be 1 and 1. So we have 0. So these two right here should be 1 and 1. So that means this is not 5. This is 3. 5, 10, 15, 16, 17, 18. 18, not 20. That's why we always check. So let's redo this math now. Because that just felt weird that they would have us do a repeating decimal. So I made a mistake, and that happens. So we're just going to erase and try again. All right, here we go. 18 and 12. So we have to divide. So 12 goes into 18. 18 up here, 12. 12 goes into 1 0 times. 12 goes into 18 1 time. It's 12. 6. Oh, look at that. I know it's going to be 5 because I know how to do this math in my head. I know 12 times 5 is 60. That makes so much more sense to have 1.5. No repeating decimals. We love when that happens. We hate when jumping happens, though. Man, it is not our friend today. There we go. you can rewind because this is 2 and this is 1.5 because we just figured that out. So if you need to get the data written down, just rewind the video a few seconds and pause it. All right, find the mean absolute deviation of Lynn's data. Lynn's data. I want to do purple this time. All right. 2, 1, 6 is 1, 4 is 1, 5 is 0, 0, 3 is 2, 5 is 0, 4 is 1, 6 is 1, 6 is 1, 7 is 2. So here we go. Let's find our 5s. 2, 3, 4, 5. There's a 5. It is being bad today. I apologize. This is taking longer than it should because it keeps jumping on me. So we're going to do that really, really fast again. Two, 1, 1, 1, 0, 0, 2, 0, 1, 1, 1, 2. So 2, 3, 4, 5. 2, 3, 4, 5. And then 2. So 5, 10, 12. So we have 12 divided by 12 data points, which equals 1. So our MAD is 1 for Lynn. And I'm going to save this. See how it pops up, says saving PDF? Then it won't. Even if it jumps, it won't disappear on us. All right. Compare the MADs and dot plots of the 3 students' data. Do you see a relationship between each student's MAD and the distribution on her dot plot? Explain your reasoning. All right, so we know Elena's MAD is 2. We know Jada's MAD is 1.5, and we know Lynn's MAD is 1. So what do you notice about their distribution? Elena's is the most spread out. Right? And then Jada's is the medium spread, right? And Lynn's is the closest spread, right? So you can see there's that spread, and then here's this spread. Just like the MAD, the smaller the MAD, the more closely the dots are clumped. So smaller the MAD, the closer the dots, data points, not dots, data points are clumped. So that means less variability. It jumped on us again and it's going to delete it. But that means less variability. Less variability. And we are finished with our lesson, so I don't need to go back. But you know, the smaller the MAD, the less variability of the data.